Newton's laws of motion and the major principles of physics can be used to describe the fast-paced game that is tennis. To begin, we will discuss the significance of the law of inertia, also known as Newton's first law of motion, in the game of tennis. The law itself states that an object has a tendency to remain at rest or in motion at a constant speed along a straight line unless compelled to change by some external net force. The motion of the tennis ball does exactly that, travels at the same speed unless acted upon by an opposing force, a tennis racket, the backboard, the hard court, or the net. The texture of the tennis ball against the wind affects the speed at which the tennis ball travels through the air.
As the game continues, Newton's second law of motion comes into play. The law pertains to the forces which act upon an object. When the tennis ball collides with a racket, an opposing force is acting upon the ball through the racket. The force is equal to the mass of the tennis ball multiplied by the ball's acceleration. The acceleration can be used to measure the speeding up and slowing down of the ball after being hit by the force of the racket.
Newton's third law of motion states that for every action, there is an equal and opposite reaction. When you hit the ball against a backboard, the force with which the ball hits the backboard is the force with which the ball is then propelled back towards you. And when you plant your foot on the ground and push off at a certain angle, your body goes in the opposite direction, at an angle away from the ground. The force with which you pushed into the ground is the force with which you're propelled forward. So, both your body and the tennis ball are operating in Newton's third law of motion.
As the tennis ball rolls across the surface of the court, if it is not pushed or propelled, then the force of friction, which is exerted by the surface of the court, will slow the ball down and eventually it will come to a stop. Friction is also at play between the player's feet and the court. Friction is the force that makes the ball spin.
When the tennis ball is hit by the racket and when it beats against the backboard, it flies back towards the player. This appears to be a nearly perfect elastic collision, where the total kinetic energy of the system is the same before and after the collision. The tennis ball appears to fly back in the opposite direction with similar momentum. Actually, when the ball collides with the racket strings, there is some elasticity in the strings that propels the ball forward. So, this is the closest example of an elastic collision. The ball actually loses more momentum when it collides with the backboard and with the hard court, but not nearly as much as it does when the ball collides with the net. When the ball hits the net, this is inelastic collision. Some of the kinetic energy has been lost by being absorbed into the soft net, so the ball simply rolls back slowly on the court instead of flying back towards the player.
As the tennis ball is hit upward, we see it travel in an arc. Its gravitational potential energy increases and it slows down as it reaches the top of the arc or its highest point. As the ball comes down, the potential energy is converted into kinetic energy, that is the energy of motion, and the ball begins moving faster due to free fall acceleration. We also see this when the ball is being served. As the player tosses the ball high in the air, it slows down as it reaches its highest point, as this is where the gravitational potential energy is the greatest. At this point, the player is able to hit the ball, hopefully with some topspin.
Backspin and topspin shots cause the ball to rotate because the racket is at an angle when it collides with the ball. This causes the ball to spin in one direction or another while moving across the court. This rotation gives the ball an additional velocity vector called the angular velocity and gives the player an advantage over his or her opponent. Backspin on a tennis ball is created by tilting the racket back and sliding it underneath the ball as it is struck. The ball spins backward after it has been hit and often even bounces back toward the player who hit it after it hits the ground, instead of spinning forward towards the opponent. This makes it much harder for the opponent to judge how to return the ball.
Directed by Crista Guthrie
and Molly Sparks.